Okay, I'm Francesco, and today we're going to talk about modular deployment in production, which in simpler words means how to split your app and run each one of your components in its own box or container. And the agenda for today will be we will walk through some use cases and try to understand what are the benefits of splitting your app into different components, and then which solutions are available to achieve modular deployment. And among those solutions, why Docker may be a better technology amongst others. So these are some use cases, and this is our minimum setup. We have a database component, an API component, and a front-end component. And usually we run everything in a single box. But we know that the front-end component is probably the weakest one because, not because Angular is less secure technology compared to Node.js, but it's just because it's exposed to the browsers, and once the code is out there, you lose complete control over your code. So if your front end is sharing code with your API and your database, and people manage to get access to your front end, then your ecosystem is vulnerable to an attack. But if you were running your app with this different configuration, like have a front-end component, then an API component, and a database component, because communication between your front-end and your API are happening only through HTTP requests, and there is no sharing of code, then that means that you have added an extra layer of security into your production environment. And if we want to make it even more secure, and let's say that you have a blog app and you are expecting content to be sent by your users, and rather than check whether the content is malicious or not into your front-end app, you may add another module, the sanitizing app, which is going to take charge of checking and validate whatever users are sending into your app. And even if the code is so malicious that everything breaks down, the component is separated, so your front end, your API, and your database will be fine. And then another use case is update frequency, and in an app that is running in production, probably we would have different update cycles, and because Spotify and Facebook user don't actually know what an API and database is, and maybe your CEO may not know either. So I would say that probably this can give you an idea of how many times you update a database, and which is going to be an update every 2 months probably, and if on your API 2 updates every month, and your front end is every day. And because your API is serving data to your mobile app as well, if you run everything in the same box and you have to update your front end, once you start the updating process, then your API and your database is down, and your mobile app is down as well. And then you run into some troubles, more troubles, even more troubles, and the CEO calls you because he's okay with the web update, but he doesn't actually understand why the mobile app is not working anymore, and try to explain that to me. So if everything was running into containers, then you may have had your front end updating by itself, and your API, database, and mobile app working without being switched off. Another use case, difference between libraries. So there is this new guy from Full Stack who wants to update the front end, and he wants to update it using Node.js version 6 because of ECMAScript 6, and the Babel transpiler node only runs on Node.js version 6. That's not actually true, but it's just to give you the idea. And the current app is running on Node 0 dot whatever, so we should have updated everything. We should update all the app to run with a newer version of Node, but if you had your app running into different components, then you may have had your front end served by Express running on Node 6, and then your API running on a less recent version of Node. And the guy from Full Stack is that. Okay. And then the last argument I want to talk about is scalability and geolocation. So your app is just launched, and you have 4 users, and the server is super happy. Then your app is growing up, you have 100 users, server happiness is average, and you get to 1 million users, and the server is down. It has to work 24 hours for 7 days at 100% of its own capabilities. But if you had everything like run into components, you may have had a load balancer, which actually is it's a computer that tries to understand, accept HTTP requests and redirects them into those components that are not so fully loaded. And your user continues to grow, so you may actually have clones of your components also spread all around the world. And those are all the use cases. So this is to summarize. We have the reason why using more than a box is security and separation of concerns and segregation of duties and environments with different versions of libraries. And more complex app may require more than the minimum setup components, so you may have even different teams working for each one of these components. And the last item is scalability and possible solutions. You may have a server for each one of these components, but that's expensive, and server may not use CPU and resources to 100%. And another solution is virtual machine, but virtual machines are actually copies of physical machines running on the same computer. And for each virtual machine, you need to install a copy of your operative system and whatever libraries you need to make those virtual machines run. But while we are developing our app, actually we are using a single computer, so the best solution would be to run the same operative system and isolate containers, so by using the same operative system and sharing libraries between each one of those containers. And that's what Docker actually does. So as you can see from this graph, on the left we have virtual machines, and we need to have a host operative system and then a guest operative system for each one of those instances. And if you had to run 2 MySQL instances, you will need to install MySQL for each one of those instances as well. And on the right side we have Docker, and as you can see, you don't need to repeat the operative system, so if you had to run 3 instances of MySQL, you may even share the same MySQL library. Last slide. What's gained is less space for each virtual box because the operating system is shared as well as common libraries, and CPU and other resources are optimized, and there is increased security because of isolated and aseptic containers, and probably the most important feature is faster deploy time. That's it. I have some other resources and image credits. Thank you.